Hello guys, in the name of God, welcome to another session to solve and discuss about some exchangers. In this session I want to talk about example 10.5, and like always let me introduce a reference of our discussion and our solution. Okay. The reference is the book Heat Transfer from J.P. Holman, 10th edition. Okay, this book has a lot of interesting problems and informations, and it would be amazing for you to understand all the phenomena which happens inside the metals and non-metals and fluid in constant to heat transfer actual phenomena. The first chapter, as I said, is introduction, and we are working on chapter 10, which is heat exchangers. About heat exchangers, okay, there are some mechanisms that transfer heat from some source to another one. Okay, so let's go back to our example. Yep. Okay. As you remember, I discussed about example 10.4 in another session, but now we want to continue that for solving and discussing about these examples. 10.5. Instead of the double pivot exchanger of example 10.4, because we discussed about that, which is a tube shell, shell and tube exchangers in example 10.5. So it says instead of that exchangers, with the water making one shell pass and the oil making two tube passes. So calculate the area required for the exchanger, assuming that the overall transfer coefficient remains at 320. Okay, so we need some let me fix it. Okay, like that, exactly. Okay, well, we need some parameters from previous examples. What are there? Okay, let me write the formula again. We have this formula: Q equals U, which is overall heat transfer coefficient. Overall heat transfer coefficient. Okay, U, which is area, and delta T M, temperature difference. Okay, temperature difference, which it has a formula that we calculated before in example 10.4. You can refer to that example and see what happened there. Okay, this U, let me change the color. This example says that example 10.4 we have an exchanger. The water goes in and goes out, water, and from opposite direction oil will come inside the heat exchanger and go out. Okay, just one by one. But in example 10.4, we have an exchanger. The water is just one way, come in and come out, water. But oil will come inside the exchanger and turn back and go from the other side. It has two way, okay, one way, two way. But in this example, it just has one way, okay. This is oil. We want to understand for this example. We knew the A for this example, which was, as you can see in this problem, in this example, A was 15.82. Let me write it here. A in example 4 equals 1582 meter square. Okay? And U is 320 watts and 2 degrees Celsius. Delta Tm, F is 1. Delta Tm was, as you can see here, 37.44 degrees Celsius, and F is 1 because for tube and shell, heat exchanger with one way, F equals 1 always, okay. But in our example, we want to know, in example 5, we want to know A. U is equal than before, 320 watt per meter square degrees Celsius. Delta Tm is equal than that, one way, 37.44 degrees Celsius. F, we should calculate F, okay? If is a parameter, I will explain about that. And finally, Q is different, okay? So in first one, Q was Q is the same, okay? Q is the same, 189 kilowatts, okay? Q is different. Q is equals just think that difference is just okay. Well, let me go through the solve of the examples. Okay, we should go to diagram 10, figure 10.8. From this case, from example 10.4, this is not what I want, this is not what I want, this what I want, this is what I want, okay? So as you can see here, in x-axis, I should calculate P, which is T2 minus T1, T capital 1 minus T small 1 and another R, capital R. I should calculate these two parameters for knowing F. Capital T1 minus capital T2 divided by small t1, small t2, sorry, minus t1. Okay, I should calculate these two numbers. So let me draw again that diagram for counter current. This is temperature, this is area, this would be cross section 1 and cross section 2. Okay, this is for oil, and this would be for water, oil. Okay, this is TC1. Because T is capital, as you can see in picture, the one way is water. As the example says, the one way is for water. Okay, and this is capital T for one way, and here water is one way. So T, capital TC1 is here, and capital TC2 is here. Which is T1. You wanted to put it here and here, and this is T2. This is T2 to put it here. Okay, but what about these two? This is TH two. We should know in this diagram the inlet is T1, small t1. Okay, a small t1 here. Let me change my color, T1, and the outlet here, outlet of oil, outlet of hot fluid would be small t2. Okay, we should put these four parameters to calculate P and R. Let's do it. Okay, let's do it. Okay, P would be 75 minus 110, 35 minus 110. The answer would be 0.467. And for that one, for this one, we have 35. Okay, minus 75, 110. The answer would be 1.143. Okay, then let's choose these two numbers in this diagram. Let's find it. P is 0.46 around here. Okay, in X axis, our P is here. But what about R? Our R is about 1.1 around here, nearly here, between 1 and 0.8. Okay, so this would be here. Okay, around here. Okay, oh sorry, around here, between, I made a mistake, 1.1, R is 1.1 as we calculated here. 1.1 here is between 1.5 and 1, so it would be exactly between, or some place like here. Okay, so 0.46 is here. It will be around 8, that one, 0.82 or something like that. Let us the parameters that the book choose, and we should make sure, yeah, it choose f equals 0.81. okay, so let me erase this one because you don't need them anymore. We found f. We should just put it inside the formula. Okay, as you can see in that, for example 4, for example 5. Okay, U, A, F, delta Tm. Delta Tm is that one. A is not the same as the previous one, but U is the same. So we want to have the same Q as the previous one. Okay, we want to same that Q. So our Q in example 5 would be 189 multiplied by 1000 watts. So okay, then A should be Q divided by U, which is the same as before, F delta Tm. Okay, Q is 189 multiplied by 1000 watts divided by 320 watts meter square degree Celsius. F is 81 and delta Tm is 37.44. The answer would be, as you can see, it would be 1953 meters square. Okay, 1953 meters square. As you can see in example 4, the A is, sorry, it is wrong, is smaller than the area in example 5. The U is the same for both of them. Delta Tm is the same and Q is the same, but the difference is between it is one way for both of fluid, but in this we are two way for this one. Q is the same, but just A is different. This A is more than that one. We need we need some more A. Okay, as you can see, it has two way. The Q is calculated the same and assumed the same for both of them. If we want to have the same area for both of them, the Q will change. Okay, you should pay attention to that and think about that This is so interesting. It was example 10.5. Thank you for watching. I hope you have enjoyed it, and take care. Have a good day or have a good night. Bye bye.